Hi, this is Ms. Carly, and this is your video for 4.1 Logarithms and Exponential Functions. This is the standard form for a logarithm, and this is the standard form for an exponential function. If you notice, they have all of the same variables. A logarithm is the inverse function of an exponential function. So just like if you have x squared, the inverse would be square root of x. If you have an exponential function, so your x is in the exponent, the easiest way to solve for x is actually with a logarithm. It's the inverse. So the little number that comes after the log is called the base. Whenever it's an exponential form, base is the number that has the exponent attached to it. The a is called the argument, and I like to think of it as the answer to the exponential form. Whenever it's already in a logarithm, if you want to turn it into an exponential function, there's a little trick called the wheel. So you start at the letter b, you start with the base, and you just go around to the x. So it would be b to the x power. You have to cross over the equal sign, a. So that's kind of how we get to this form pretty easily. It's just a little trick to help you remember. But B stands for base. You're used to seeing this called the base. You should have been seeing that for quite a long time now. And A is the argument. Whenever it's in a logarithm, A will be after the B. That's usually where all the numbers are. All right, now your calculator only has two kinds of logs. If you see the button that actually says log and the one that says ln, ln is the natural logarithm. Log has a base 10. So natural log is the inverse of e to the x. Natural logs have a base of e. E is not a variable. E is a number, kind of like pi. It stands for 2.7 something or other. Log has a base 10. So if you wanted to cancel out 10 to the x power, you would use log. So I have an example up here of how we would change from exponential form back and forth to logarithm. So if you notice, 8 is my base, and that's the little number after the log. And 64 is the answer to my exponential equation, so that becomes my argument. And a logarithm is easy to solve for the exponent because it's on the other side of the equal sign. You should already have these two numbers, and then you can plug them into the calculator. Now, the problem is that your calculator's only two options are to have a base 10 or a base of e, and our base is 8. This is called change of base formula. Basically, all you have to do in your calculator to figure out what number this equals is do the log of the argument, which is the bigger number in the problem, divided by the log of the base. The base is always on the bottom. That should be easy to remember, base, bottom. So when you type in log 64 divided by log 8, it should look like that in your calculator, and you should get 2. That should make sense because basically what you're saying is 8 is my base. I need to raise it to this power, and my answer needs to be 64. Well, 8 raised to what power is 64? 8 to the second power is 64. This can be easier to solve because you don't really have anything to do except plug this into the calculator. If you wanted to solve for this, you would need to put this into y1, this into y2, do zoom out, zoom fit, second trace 5. This kind of is a little bit easier if you can remember that it's the inverse for exponential. All right, let's try to solve an equation, and this is going to kind of tie together some of the properties of logarithms that you would have seen in class today. All right. Sorry, I'm trying to get rid of that glare. You have two different logarithms, but they have the same base. You're not allowed to do anything with logarithms that have a different base. You won't have questions where the logarithms have different bases. But I have two of them, and I need to bring them together. So it's kind of the opposite of your laws of exponents. If you were trying to multiply two terms together that had the same base, but their exponents were different, all you would do was add the exponents. We're going backwards. It's like we have the exponents, and we're trying to condense them back. So ours looks like this, L log plus the other log. If we want to condense it, which means bring them together, we need to go back to this form. So actually, whenever you're adding two logarithms together, if you want to condense them, you multiply the arguments. So that would be log base 2 times x minus 2 equals 3. Now, this is not going to be very easy to type into the calculator. I don't know what x is. I can't do change of base. So this is one of the situations where it's going to be easier for us if we can switch this to an exponential equation. If you had numbers here that you could just plug into the calculator, the log form would be easier. So I'm going to use that trick of the wheel to convert it, and then I'm going to check and make sure that I put everything in the right spot by remembering what they're called and where they're supposed to go. So I'm going to start with the base. The base gets raised to the exponent, and that's supposed to equal the argument. So if my base of the logarithm is 2, that means I'm starting with 2 as my base. Your exponent is over here. And the argument is the answer to the exponential form. All right, 2 to the third power is 8. I just have to solve this now like a regular equation. Now, you should be able to tell that this is going to be a quadratic equation. So I'm going to go ahead and move that 8 over to the other side so that I can factor it. I just like to factor and get my answers that way. So I need factors of negative 8. Put that there so you remember that we subtracted it. Factors of negative 8 that add up to negative 2. So what are the factors of 8? We have 1 and 8, 2 and 4, and that's pretty much it. So I have to use 2 and 4. If I want for them to add up to a negative 2, it needs to be x minus 4 and x plus 2. So I'm going to check. They add up to negative 2. They multiply to negative 8. I'm good. I can now solve this and say 4 and negative 2. There's something that we have to be careful of, and I'm going to pull up the graph of what the logarithm and the exponential function look like. This is the exponential function. It has a horizontal asymptote at y equals 0. If you have an exponential equation, your y value will never be 0. If you look at the logarithm, I know it's hard to see, but it actually has a vertical asymptote when x equals 0. The domain x has to be greater than 0. Now, that's not always what you get when you solve for x, but whenever I plug it in, I'm not allowed to have any argument that comes out to be a negative number. Otherwise, the calculator will give you an error message. That's because that vertical asymptote is basically saying your argument is never allowed to go past 0. It also is not allowed to equal 0 because that vertical asymptote, it will never actually be 0. So I need to take my solutions and plug them in and check and make sure if A, your argument comes out to be negative, that is an extraneous solution. So if I plug in 4, that's positive. 4 take away 2 is positive, so that works out. But if I try to plug in negative 2, your answer comes out to be negative. And you could even try, if I was going to try to put this into the calculator, change of base says that I would have to do log of negative 2 divided by log 2. Like that, your argument divided by the base, and it gives me an error message, non-real answer. Basically, you're not allowed to divide by 0. And if you look at the graph, that's because you're never allowed to go into the negative side of the graph when you have a logarithm. Your x's will always have to be positive. All right, so hopefully you have a little bit of a better understanding of how to use the wheel to go from logarithm to exponential form. And hopefully you understand that they're inverses of each other, and we have to kind of use these condensing rules when we're solving logarithmic equations.